Good morning. Welcome to our presentation where we will provide you with an insight into the Stockholm Bypass Digital Twin, which we've created. My name's Stuart Wilson and I lead the ITS consultancy team at NICANDER, and I'm joined by my colleague Jonathan Archer, who has led the development of the digital twin. We only have a short time slot and we're actually keen to show you the digital twin rather than just talk about it. So we've got a few slides, but then we're going to give a demo. Our presentation includes a brief overview of the scheme, an introduction to our digital twin high-level principles and workflow, where it fits in relation to the construction design life cycle and the gap it currently fills between detailed 3D construction design information and a digital twin which is interfaced with real operational technology and systems, and finally a quick demo. Our digital twin is of the Stockholm Bypass in Sweden, which has been developed in the Unreal Engine. As of last year, it's operationally in use and being used to support testing and commissioning of operational technology assets. Although the digital twin presented is within a tunnel environment, the process we've developed is the key part in relation to the integration of 3D construction drawings with operational technology, data, and operational systems. This process can be applied to create a digital twin for other environments in the same way by using the same workflow to combine environment-specific model information, data, operational technology, and systems. For example, it could be used to create a building or monitoring above-ground transport networks. The digital twin was developed to support operational technology simulations and verification during construction, but can also be used beyond construction to support asset management activities, maintenance, and operations.
So this is a very high-level overview of the principles behind creating the digital twin. So we've got a digital twin in the center that's built on Unreal Engine. On the left-hand side is the 3D model and integration data, and it's very important that these need to be linked together before they come into the engine. Sitting on the top is a control system, which is effectively acting as the brain of the digital twin. It drives its state. Any changes in the control system get reflected in real time in the digital twin. And then we can use that same interface as well to connect assets directly into the twin as well. So you don't need it, but it's sort of quite an important part. We also are able to bring third-party data in, so we've used LiDAR and photogrammetry data to sort of create above ground areas. Stuart, if you go to the next slide, please. This delving slightly more into that those principles, there was two main challenges that we faced with creating it, and the first was a large amount of data for the model. So we have over 8,000 drawings, and we extract information with software like Navisworks, Datasmith, and Dynamo. That's more specific to a 3D model, but if we're doing something like 2D or browser-based, we would obviously adopt the same principles, just use a different workflow. The other was actually creating the interface that would allow for an always up-to-date representation of the assets in the system. This is where that integration data really is key, and we need to have enough information to link an ID to a model to then be able to link that to an asset on the system. It's also a thing that separates it from being a 3D model and becoming the digital twin. So we bring all of this information into the Unreal Engine, which is effectively the user interface. All functionality for interacting will be through that. And then again, if this was 2D or browser-based, you'd probably swap that engine out for some more appropriate software, but that's just how our sort of process goes. Stuart.
To create the Stockholm Bypass Digital Twin, we used scheme design data, as Jonathan said, as a basis to create a 3D environment. However, it doesn't necessarily need to be 3D or need to be CAD data either, in the same way that these techniques are not restricted to using the tools to build a tunnel environment either. For example, we can collect data using drones or LiDAR to build 3D models of any environment, and we have done this successfully using drone-based photogrammetry techniques. My background as a designer includes experience in the design, construction, and handover of operational technology in the highways environment, and we create 3D models to support clash detection during design and to support construction activities and the phasing of construction works. The 3D model data is not normally used beyond the construction, and one of the reasons for this is the gap in the skill set between the design teams who create the 3D models, the contractors who build the schemes, and the software specialists that develop the systems which integrate the operational technology with the actual control systems. The Stockholm Bypass Digital Twin fills this gap and continues to make use of the design data by interfacing it with the live control systems and the actual operational technology assets. And now it's time for a demo. So hopefully you can share your screen, Jonathan.
Okay, so thanks, Stuart. So if there's anything that looks out of place here, that's intentional because the project is still under construction. We've got a process that allows us to keep this twin update and when new information comes into it. It's designed to be sort of a fully interactive environment. So at the moment, I'm sort of attached to this zip line that runs up the center of this carriageway here. I can sort of move myself along it, backwards and forwards. I can sort of pan around. I can sort of give you a little bit of an idea of sort of scale there from outside and what it looks like with the roof on and off. So I can sort of navigate up and down here. Everything so we integrate over 20,000 assets into this model. They all are individually represented. So these fans on the ceiling are classed as their own asset. I've got a barrier down the back there. I can take us up to this gantry. So the gantry itself will be individually represented as well as each sign on it and the detectors that sit behind. Selecting so I can sort of select this information to take us directly to one of them. And that works throughout the whole tunnel. So I can sort of go directly there. I can then sort of highlight the things of interest and see what information about them. If I just step back again, every single one will also include their own sort of property sheet. I've deliberately selected a one with missing data here, so it sort of is a representation of what an operator would actually see. I will take us up to the other side of the tunnel, which does have assets with sort of data set on them. In fact, actually, I'll do that now, and probably to give you a good idea of the idea of the how many assets are in the model. If I do that, we've got like 600, and I know that this is just for a signal, so that's 600 signals, and we've got significantly more than that. So we've got a huge variety of equipment in here. If I just sort of limit that search to 061, this is reporting everything with 061 within its name. And each one of these is a drop down that can be expanded, which will have varying amounts of equipment in it. If I take us to the north side, this one, and I'll go to this one here. And while that's loading, I'll just say the primary use case for this is testing assets and allowing something like an action plan to be ran. I want that one actually. That will allow an operator to validate that the correct ones are being set in the correct position. So it allows them to do all of that before it gets installed. And here we go. Here's what some of those signs will look like when they're set. And we can we can run a plan from the operational side of things. We can see what values are being set within this sort of environment and see and validate that your plans are correct and that they tie in with what you want to show when there's a crash or you need to close a lane for whatever reason. If you want to set like a barrier to be open, again, sort of being able to do that.
30 seconds left, Jonathan.
Yeah, so I'm conscious of time, and we've got like loads we could show with this, but I think I'll have to just probably call it there and say if anybody has any questions, if we could keep it to sort of a technical sort of side of questions, that would be ideal for us, I think. Thank you very much.
Our next question, Stuart and Jonathan, to yourselves is, what are your biggest problems in getting the different disciplines to collaborate across the multi-decade life cycle of the bypass?
I think it's a really good question, and I guess we don't have the answer immediately, but one thing I would say is that as we've started to introduce 3D models in the design phase, we've seen a shift where the different engineering disciplines and designers collaborate to create the 3D model. And as we start to see more data and joined up solutions like the digital twin, I think that needs to happen as well. So I don't know what the answer is, but certainly in the design perspective, those disciplines have come together, and actually what they've created is a better solution overall by sort of collaborating with each other. We sort of see in terms of operations, that'll be a similar sort of process.
Brilliant, thank you. And Jonathan, a slightly linked question, but to you and Stuart as well, is what skill shortages do you experience and how can we overcome them? Particularly any advice on in-house training and competency?
Yeah, I think it's a difficult one. It really depends on sort of the digital twin that you're going for. Like, I would say that we are primarily a software company. So we've kind of had to sort of look at expertise for the game engine, for the Unreal Engine side. We've had to look at expertise from the BIM side, for the CAD side of things, and then it's trying to find a way to link all that up and make sure you've got an understanding of those things across everybody who's working on the project. It's really quite a tricky thing. So you kind of need a little bit of a specialism in all those areas, and then to try and corroborate it between everybody. But it's, yeah, I don't know how better to put it, to be honest.
Thank you. And our final question, Jonathan, for yourself is, which tools have you used for modeling digital twins? Can you please share information on the supporting tools for visualization?
Yeah, so I would say that the visualization and the sort of user interface, that's all through the Unreal Engine. To actually create the sort of the models from the CAD data, the BIM data, we'll use a variety of different softwares. We'll use AutoCAD, we'll use Navisworks. So Navisworks has a nice little plugin called Datasmith that allows you to sort of use essentially extract 3D assets from it. So we use those as a basis. We do a lot of work on top of that to sort of create scripts and whatever else to pull certain bits of information out. That's where the bulk of the work really is for us. Yeah, so I think Dynamo is another one for if we wanted to generate a little bit of extra information.